Hello everyone. So we are going to give a three-voice presentation exploring how the reuse of the treated wastewater can be considered an adaptation solution for agriculture using an interdisciplinarity approach. Okay. Our reflection is grounded in the French context, where since 2010 a regulatory framework has been developed to govern the reuse of wastewater, a practice that was at the time emerging from only sporadically. However, when this regulation was being drafted, a lack of scientific knowledge was identified to adapt international standards to the French context. So to produce the missing knowledge, the establishment of experimental sites has been encouraged by institutions, and this knowledge is therefore situated in the sense, that it is produced within a specific framing that supporting public policy and regulation. And this framing explains that the research questions that are commonly raised in the field of treated wastewater reuse, on the one hand, questions related to the risk for human health, and on the other hand, issues of feasibility. So since 2023, the French government has been promoted the development of non-conventional water uses, and then for accelerating the adoption of treated wastewater use. This shift implies moving from an experimental scale to a territorial one, involving local population and the practical implementation of wastewater reuse. It is also introduces new temporalities, no longer those of experimentation, but of the long term. In other words, knowledge production is embedded now in a new framing. Previously, it aimed to ensure the feasibility of wastewater reuse under safe conditions, and today it must assess whether wastewater reuse can be considered an agricultural adaptation solution in the context of climate change. So this shift requires renewing research question by engaging new disciplines or engaging existing ones differently. So in our case, we have re-examined treated wastewater reuse in society with an interdisciplinary approach based on two case studies located in the south of France. But we will only present today only one constraint the time we have. So I leave the floor.
Good afternoon. So I will give you some information about the site. We are in the south of France, in the region of Narbonne, which we have the main culture is grapevine, which was not irrigated, but it's changing. We are also in a tourism area, so we develop some waste reclaimed water for irrigation of grapevine. Nowadays we talk about 50 hectares of grapevine connected to the reclaimed water system. So we are on the coastal, so we have some salts in the water, and the question is what could be the impact of the water reuse on soil quality. To answer this question, we sampled two different plots with different soils, a sandy loamy soil on the coastal plain and a clay limestone soil more in the inland. We sample under the drippers where water is applied and in the interwar of grapevine where there is no water on two horizons. The sampling campaign was done in 2025 after the two first irrigation campaigns over 2 very dry years. And I give you some data of the amount of irrigation. I will only show one result with one indicator, the exchangeable sodium ratio. So we have the two plots and the two horizons. and we have pair of bars. The bar with the star corresponds to the interrow where there is no result. So what can we see? We have an effect of irrigation. The exchangeable sodium percentage is of irrigated rows is more significant than in the interrow, and we also have an increase with the dip. So water reuse provides more exchangeable sodium that it can leach. We also have a plot effect. In the sandy loam plot on the coastal, the soil is moderately sodic, and we can have some agronomic disorder related to sodium, which can develop in the vines. So we observe some accumulation of sodium in the soil, sodium enclosures, this accumulation depends on the type of soil and the water dynamics within it. But we have two kinds of incertitudes. First of all, we have 2 dry years, but in the winter we have some rainfall. And so what will be the frequency of rainfall events allowing for good soil leaching? And the other incertitudes, we have an impact of the sandy soil on the coastal. The wastewater treatment plant is at the same level, so how will seawater infiltration phenomena in wasted water networks evolve in the long term? Will we need some to add some desalination operation, because this infrastructure has some cost, and Maria will talk about the cost.
To switch on the economic part, we try to answer to the question of is it interesting to promote reuse from an economic perspective? And to do that, we need to compare. Yes, not a problem. The system, the reuse scenario to the non-reuse scenario. And usually we have this. That is that the reuse scenario is really high, and it seems really interesting compared to the non-reuse scenario, which tends to be without any adjustment. But in reality, when we observe the scenario, we have something which is less evident, and we have something like that, for instance. And I just show you one indicator, which is the water cost paid by farmers in the Irialto case. And it was planned that it was less than 40 cents, and in reality, it's more than €1. And then it's not the same. And this observed scenario has to be compared not to the no reuse scenario, but to another one which is difficult to assess, but which is essential. It's what we call in economic the counterfactual scenario. This counterfactual scenario is a scenario which is realistic, credible, taking into account all factors like environmental, economic, agricultural, climatic, etc. And this can be something which is really similar to the reuse scenario, and it points out the interest or not of the implementing a reuse project. And this, no, it's not a problem. I wanted only to show, first of all, the first part of my slide. This is needed because if we say, okay, this scenario is interesting, we have to promote it, even if it's not interesting financially for farmers. And then, in other way, we have to reject it. And if we have to implement it, we need to ask who have to pay for this project. And we just assess what was the share of the cost between different stakeholders in the Agricultural project. And what we find is that, as you see, is that investment cost is not supported only by the beneficiaries, the farmers, but also by subsidies through local or public authorities funding, and also subscribers to the public sewage system. And it's the same for operational cost. And that means that we need to discuss with the stakeholders to know if we have to implement a reuse scenario or not. I will finish my presentation.
It's a challenge to make a free voice presentation. So to conclude, we can say that our interdisciplinarity approach, which examines the shift of wastewater use from experimentation to society, highlights the fragility of the promises and the narrative associated with the wastewater reuse for agriculture. For example, while the promise of securing water supply may help stabilize yields, it is rarely accompanied by a coherent agricultural policy, or even if today my colleague doesn't speak really about that. And another example is related to the promise of the valorization of nutrients contained in the wastewater, which denied the impact of water reuse irrigation on the soil health in the long term. So it was just that we want to say today. Thank you.